All right, so now that we know what exponential functions are, the input is basically up in the exponent. We're going to basically take a look at two different types of exponential functions. The first type is what we call the exponential growth function. It basically, using our notation, f of x is equal a to the x, and our a's are greater than 1. So if you look at my examples here, right, a is equal to 2, so it's bigger than 1. Right, a is equal to 3, so it's bigger than 1. A is equal to 4, and a is equal to 3/2. So for our sake of argument right now, we're going to assume our bases are greater than 1. And then what we're going to do is investigate what happens when we start using x as the exponent rather than as the base. So as we do with any graph, what we do is we use our point plotting skills. And so we'll just throw in some numbers. So let me start building a little table here. And it's always good to throw in some negatives and 0 and 1 and 2. So let's see where that takes us. So if I was to let x equal negative 2, what we're going to have is 2 to the negative 2. And of course, the way we handle negative exponents is by rewriting them as a reciprocal, if you would. And so we end up with 1/4. So that gives us a point to plot, right? So one of our points is negative 2, comma 1/4. If we let x equal negative 1, we're going to get 2 to the negative 1, which gives us 1/2. So that's another point we have to plot, negative 1 and 1/2. If we throw a 0 in there, we've saw in the past, way back in chapter 4, that anything to the 0 power is 1. So another point on our graph is 0, 1. If we throw a 1 in there, right, raising 2 to the first power gives us a 2. All right, forgot the 1 there. And if we throw a 2 in there, we get 4, right? 2 squared would be 4. So we basically have a couple more points to plot. So I usually ask for 3, but here's 5. Let's see what we got. So if I plot, let's plot the easy ones first. So one of my points is at 0, 1. Another one of my points is at 1, 2. And another one of my points is at 2, 4. The tougher ones at negative 1 were roughly about a half. Let me make that even nicer, kind of. All right, so about a half. And then negative 2 is 1/4, so that's even closer. All right, and because I kind of know what's going on, all right, you can kind of get a feel that if we increased x here, right, we're going to get an 8. So coming from our intercept, the function is basically going to move up very high, and the arrow indicates that it's going to go on to infinity very, very fast. As opposed to on the negative side, notice that the fractions are just getting smaller and smaller and smaller. So on this side, what's going to happen is we're just going to get tinier and tinier and tinier, and that arrow indicates that we're just going to get closer and closer to the x-axis. So there's your graph of f of x equals 2 to the x power, all right? And our first glimpse at an exponential function. So what happens when the base turns to 3, right? So again, building a little table here, right? Let's throw in the same x values just to kind of get a feel. 3 to the 0 power, again, is 1. 3 to the first power is 3. And 3 squared we know to be 9. So again, you can kind of see that as x gets big positively, the outputs get really big really fast. If we throw a negative 1 in there, we get 1/3. And if we throw a negative 2 in there, we effectively get 1/9. So you can see, as we saw over here, right, with the 2 to the x, 3 to the x behaves very similarly. The numbers are obviously different, but we're going through 0, 1 as our y-intercept, right? We're going through 1, 3, and then 2, 9. So right away, the function is really going fast. And then in the x direction, we're at 1/3, and then we're at 1/9. And in the negative x direction, we just get closer and closer to that x-axis. So you can see the graphs look very, very similar to each other. So with that, right, we can probably, if we move to the pages down below here, right, you can imagine what we're probably going to get if we had 4 to the x and 3/2 to the x, right? If you're kind of using your anticipation skills, right? Let me try to get this nice and straight. I don't know if that's straight, but right? If you're anticipating, right, you're thinking that it's going to be a graph like this. So let's just do some point plotting and see if that's the case. So again, let me use -2, -1, 0, 1, and 2. 4 to the 0, right, is 1. 4 to the first would be 4. 4 squared is 16, so you can see that it's getting big really fast. 4 to the -1 would be 1/4, and 4 to the -2 would be 1/4 squared, which is 1/16. So there are our points to plot. And you can see that our anticipation was correct, right? This is also going through 0, 1, and then it goes to 1, 4, and then 2/16, which would be way up here. So it's really exploding fast. And in this direction, it's 1/4, 1/16, and it's getting closer and closer to the x-axis. So again, is very similar to 2 to the x that we had up here and 3 to the x that we had up here. What about 3/2 x? Well, again, we're anticipating this same basic shape going through 0, 1, but that's anticipation. Let's go ahead and make sure we see that. So let's start with an easy one first. So if I take 3/2 and raise it to the 0 power, again, anything to the 0 power is 1. So 0, 1 is in our graph. If I raise 3/2 to the first power, right, that's going to be 3/2. So we have 1, 3/2 on the graph. And if we raise 3/2 to the second power, we get 3 squared over 2 squared, which is 9/4. Okay, so you can see it getting bigger. On the negative side, if we take 3/2 and raise it to the negative first power, right, well, this will be 3 to the -1, 2 to the -1, and flipping things through, we end up with 2/3. So -1 and 2/3. And if we did that to the -2 power, right, we're going to get 3 to the -2, 2 to the -2, which is 2 squared over 3 squared. We end up with 4/9. So -2 and 4/9. So starting with an easy point, again, we're going through 0, 1. 1 and 3/2, so 1 and 1.5-ish. And then 2, 9/4. 4 goes into 9 twice, the remainder of 1, so that's 2 1/4. So you can kind of see it's not going as fast as these guys, but it is on its way up. And in this direction, right, -1 is 2/3. 4/9 is about, just a little bit under a half. So you can see in this direction, it's also behaving similarly, where it's never crossing the x-axis, just getting closer and closer and closer. So there basically is kind of a glimpse at what the graphical behavior is. You can see the basic shape is the same. They seem to have the same y-intercept. In the positive x direction, they are starting to grow very fast. And in the negative x direction, they're basically declining very, very slowly and getting closer and closer to that x-axis. So classic exponential growth behavior, right? And you might have heard this phrase when we're describing money, all right, or population, right? As time goes forward, if we're experiencing exponential growth, right, what you're getting is a population explosion. And that could be a good or a bad thing. All right, so I'm almost 9 minutes into this introduction. So how about I stop there and we'll summarize a growth function in another video coming soon.